So consider the following region, which is bounded by 3x squared minus x cubed. So this is how it looks like. It's a cubic curve and y equals to 0. So this blue region, and you want to rotate it around y-axis. So you rotate it around y-axis. So it will look somewhat like that. Now, question is, how do we find out volume of this resulting solid? So one way is the following. So you basically find out the outer radius. So now you have y equals to 3x squared minus x cubed, right? So since you're going to rotate it in y-axis, if you want to use the disk method, you need to find out what is this value, r outer, in terms of what? In terms of y. So you have to solve for x in terms of y. Now it's a cubic equation. This is already difficult. To solve for in terms of what? In terms of y. So solving x in terms of y is difficult. So that's why we'll try to come up with a new method. Okay? And the new method is basically the following. It's called cylindrical shell. So again, the idea is you have this region from A to B, and you have this shaded region. Now, instead of, and you're rotating it around, say, y-axis. So you're rotating it around. So the rotation is happening around y-axis. Now think about it in the following way. Instead of basically, when you rotate around y-axis, you get a region like this, and you could basically get a cross-sectional area like that, right? And then there's the inside cross-sectional area. But instead of doing that, what you do is the following. You take one length like that, and you rotate this around. And find the volume of this shell. Yeah, sorry, it's the volume of this cylindrical shell. Yeah, or rather area of the cylindrical shell, because it's a very thin slice. So you basically take this guy and rotate it around like that. And then you keep on doing it for the next one as well. For the next one. And you add all these areas up using the integration. Okay, so let's take x in AB. So let me just erase this so that you can see. So let's take x in AB. Now let Lx be the line segment inside the region R joining x0. So this is x0. And on the top, there will be f of x, x f of x. So you take this line. Imagine this line is red colored. So let me just color it red. Now rotate this Lx around y-axis. So I'm going to rotate this Lx around y-axis. Yeah. Now, so you can see this red cylinder with radius r and what height f of x emerges when you rotate it around the y-axis. Now, this be your cylindrical shell. Let's call this as Cx. Now, the shell is like a skin only, right? It's not filled in. So just a thin skin on top outside. So now you want to basically compute the surface area of this shell. All right. And which surface area? The slant surface area only. You do not care about the top, but you want to compute the surface area. So if I cut it like this, you can get a rectangle. The width of this rectangle is going to be what? The width of this rectangle is, since you're rotating here, the width is going to be, what is the width going to be? So the width is basically going to be this part here. So that is going to be 2 pi x. And the height is given by this height, which is f of x. So what is the area of this skin or cylindrical shell, it's going to be 2 pi x multiplied by f of x. So 2 pi x f of x. And then you want to basically add areas of all this skin. So you will get the volume is integral a to b ax dx, which is 2 pi x f of x dx from a to b. So this is how you get volume, by adding all of these areas up. So this is the concept of cylindrical shell. So you see here, you're not finding area of the disk. You're finding the area of the shell, which is like a skin. All right. So such a thing is called method of cylindrical shell. So let's look at an example. Find the volume of the solid obtained by rotating about the y-axis, the region bounded by the curve y equals to 3x squared minus x cubed and y equals to 0. So first you will basically find out a typical shell. So a typical shell will be of this height. So x, then you rotate it, it will look like that. So what is your A of x? The area of the shell is going to be the base perimeter, which is 2 pi x times the height, which is given by f of x. Right? So therefore, the volume is adding all these shells up. So going from where to where? 0 to 3. So 0 to 3, 2 pi x, 3x squared minus x cubed d of x. So this is the volume of your cylindrical shell. So note that generally here in the diagram, we are already given this 3. Otherwise, you will have to solve for it. So how do you solve for it? So we get 3 minus x cubed equals to 0, because that's where y is 0 at these points. So you get 3, take x squared common. What is left in the bracket? So 3 minus x equals to 0. This gives me x equals to 3 or x equals to 0. So you add all these shells up and this is your volume. If you want to compute it, let's go ahead and do this. So 0 to 3, 2 pi comes out, 3x cubed minus, what do we have? We have 3x cubed minus x to the 4 dx. This is going to be 2 pi x to the power 4 by 4 times 3 minus x to the power 5 by 5, 0 to 3. Now this is going to be 2 pi 3 to the power 5 divided by 4 minus 3 to the power 5 divided by 5. And that is going to be 2 pi 3 to the power 5 minus this guy is going to be 3 to the power 5 divided by 20. Or this is going to be 3 to the power 5 times pi divided by 10. So this is your answer. Now let's move on to the next problem. Again, the same way. So find the volume of the solid obtained when you bore a circular hole of radius A through the center of the solid of radius B greater than A. So you basically can think about, you have a sphere like that on top. Yeah. And then what you do is you basically, you have a hole, you have the whole center of the solid sphere and you are basically cutting it off. So just let's restrict ourselves in the upper hemisphere. So you have cut down what? You have basically cut down a circular hole of radius A. So this is going to be, this length is A. And the radius of the sphere is B. So this total thing here until here is B. Now, first things first, we are going to use a cylindrical shell method. So first thing is this height. So this is your x. So you need to find out a of x. So how do we go about it? Now we need to find a connection between y and x. So again, in this case, you'll be given by x squared plus y squared equals to b squared. And then you get what? Y equals to square root of b squared minus x squared with a plus or minus sign, but we are considering the upper part only. So we have y equals to square root of b squared minus x squared. So what is my ax? Ax is going to be 2 pi. What is this width? This width is x times f of x, which is b squared minus x squared. And where are we integrating it from? From A to B only, right? Because this is a region we are rotating around, right? So we get our volume is going to be A to B 2 pi x square root of b square minus x square dx. And since we are also considering the bottom part of this guy, right, we need to just multiply this by 2. Yeah. So how do we go about it? You can use the substitution. So how do you use substitution rule? So let b square minus x square be u. In that case, what do we get? We get 2x dx with a minus sign equals to du. We need to change the limits of integration as well. So when x equals to a, your u is b square minus a square. And when x equals to b, your u is b square minus b square, which is 0. So therefore, the volume becomes 2 times a, which is instead of a, I will have now what? I will have b square minus a square. On top, I will have 0. Instead of 2x, I will have du with a minus sign. So minus du. Pi will remain as it is. And instead of b square minus a square, I will have square root of u. So this is going to be, what is this going to be? This is going to be minus 2 pi. What is the integration of square root of u? U to the power 3 by 2 divided by 3 by 2 du. Sorry, my bad. Right? And then the limits of integration are b square minus a square to 0. So when you put 0, you will get 0. When you put b square minus a square, you will see minus of 2 pi with the minus of b square minus a square to the power 3 by 2 divided by 3 by 2 is same as multiplying by 2 by 3. And now you can simplify it. So it's going to be 4 pi by 3 times b square minus a square to the power 3 by 2. So this is how you find the volume of this object. Okay. So the volume of the solid which remains after you bore a circular hole of radius a. Now, the same problems which we did in using disk method or washer method now can be done by using shell method as well. Okay. So how do you go about it? So consider the region in the first quadrant bounded by y equals to x, y square equals to x, and y equals to x cubed. Use method of cylindrical shell to compute the volume obtained by region, rotating it around y-axis. So when you rotate it around y-axis, you will basically see something of this sort. Right? So now you will employ the method of shell So around y-axis. So we need to basically find the cylinder which you're going to rotate. So the typical cylinder will look like this. Okay, so this is how your typical cylinder will look like. So again, you have to find the base radius, which is x. So a of x is going to be 2 pi x times f of x. But now you don't have the total height. You have the top height minus the bottom height. So how is the top function given by y equals to x, y square equals to x, which is same as saying y equals to square root of x. So you have top height, which is square root of x minus the bottom. So this total thing is square root of x. And out of that, you're removing this value, which is x cubed. So what is the volume then? Volume V equals to what? For that, we need to compute the points of intersection. So points of intersection. So points of intersection. So when two things intersect, the x and y values become same. So now we want to solve for x in this case. So we'll equate y values. So you can see that you will get square root of x equals to x cubed, or you get x equals to x to the power 6. This implies x to the x minus x to the 5 minus 1 equals to 0. This means x equals to 0 or x equals to 1. Yeah. Fifth root is so x to the power 5. The fifth root is a 1 function, so you'll only get one value. Other way to look at that is factorize. You'll see that it has only one solution. So then the volume is going to be, what is the volume going to be? 0 to 1 a of x dx, which is 0 to 1 2 pi x times square root of x minus x cubed dx. And if you want to solve it, let's multiply it out. So we get 0 to 1 2 pi x to the power 3 by 2. Let's take 2 pi outside. 2 pi x to the power 3 by 2 times x to the power 4 dx. And then you get 2 pi x to the power 5 by 2 divided by 5 by 2 is same as multiplying by 2 by 5 minus x to the power 5 by 5. 0 to 1. When you put 0, you won't get anything, but when you put 1, you get 2 pi 2 by 5 minus 1 by 5, which will give us 4 pi, sorry, my bad, 2 pi minus, so this is going to be 2 pi by 5. So this is your answer. All right. Again, the idea is straightforward. What you need to do is you need to find this height. After all, you see, you're finding the cylinder, right? You're finding the surface area of the cylinder, the curved surface area. So you need to find out this height, and then you're multiplying by what? The base rate, the perimeter of the base, right? Because after all, when you cut it like a rectangle. The bottom part cuts as 2 pi x, and this part cuts as what? The upper curve minus the lower curve. So if the upper curve is f of x, lower curve is g of x, then it's f of x minus g of x. Okay. Now let's do the same problem with respect to what now? X-axis. So now we want to rotate this region in x-axis. So in this case, we are rotating in what axis? We are rotating it in x-axis. So you have this height, and then you're going to rotate it around like that. And you need to find out the area of this shell first. So in this case, this is your y. Now you need to basically find out the value of this. This is the x value, but written in terms of y. So for first one, you have y equals to x cube, or you get x equals to cube root of y. For the other one, you have x equals to y square already. So what do we get in this case? So area is good. So a of y is going to be 2 pi y, right? Because this is y, times what? What is the total length? So this is this whole length minus the small length here. So the total length is, the bigger part is cube root of y minus this part, which is y square. So this is your a of y. And again, we need to find the intersection point, but the intersection point was already computed for us in the previous problem. This was what? The x value was 1, so y value is also 1. So the integral is going to be giving us the volume, and the volume is going to be 0 to 1, 2 pi y cube root of y minus y square dy. Now you can take 2 pi outside, 0 to 1, y to the power cube root is same as 1 by 3. So 1 by 3 plus 1 is 4 by 3 minus y cube dy. Now when you integrate this, this is going to be 2 pi. Integral of this is going to be y to the power 7 by 3 divided by 7 by 3, which is same as multiplying by 3 by 7, minus y to the power 4 divided by 4. So what do we get in this case now? Now we need to cross multiply, right? So, oh, sorry, my bad. Put the limits first. So 0 to 1. So when you put 0, you get nothing. So when you put 0, you get 0, not nothing. And then when you put 1, you get 2 pi 3 by 7 minus 1 by 4. And then you get 2 pi 12 minus 7, which is 5 by 28, which is 5 pi by 14. So now let's look at the following problem. So we have y equals to x square, y equals to x cube, but instead of rotating it around x or y axis, we are rotating around line x equals to 1. So how does line x equals to 1 looks like? So this is your line x equals to 1. See, so in this case, what you have is you are taking this line and rotating it around x equals to 1 like that, right? So now, what is the length of this guy? And you need to find out what is the circumference of the bottom. So now let's see. So everything will be in terms of x now, right? So what is this part here? So this will give you the circumference of the bottom. So if the total thing, if this part is x, right, above, you're looking at above x, exactly. So this is going to be 1 minus x, right? And what is your height? The height of this part is going to be upper height, which is basically y equals to square root of x, because you need to write in terms of y, and the bottom one is x cubed. So the height f of x, so f of x, the top height is square root of x, and g of x, the bottom height is x cubed. So let me write down the a of x. So a of x is going to be 2 pi 1 minus x times the height, which is going to be upper one, which is square root of x. The bottom one is x cubed dx. And again, where is your x changing from? Your x is changing from all the way 0 to 1. So this is expression for for your for your volume, right? Okay. So the good rule for thumb for the fall, which method to use? If the area section or strip is parallel to the axis of rotation. So suppose you have like that. If the area strip, so if you take this guy, your area strip is parallel and you're rotating it around y-axis. Your area strip is parallel to what? Y-axis. So in this case, we'll use shell method. Yeah. Now, if the area strip is perpendicular to the axis you're rotating, like in this case, then you will use what? Washer method or disk method. So these are the methods, two methods for finding the volume.